Good morning to all of you. This is Jyoti, Postdoctoral Research Associate at BMB UNMC. I am thankful APA members and judges for providing me nice opportunity to present my research work entitled Repurposing of Antihelminthic Niclosamide as Novel Anti-Cancer Drug for Pancreatic Cancer. We all are very well known. Pancreatic cancer is one of the most lethal form of cancer associated with poor prognosis and low survival. However, lots of effort has been made in past decades in which drug repurposing is common practice. By using this approach, lots of drug gain importance in which niclosamide is center of attraction. The basic mode of niclosamide is mitochondrial uncoupler. It is a FDA approved drug. As an anti-cancer efficacy, it can modulate various molecular signaling pathways such as Wnt signaling pathway, mTORC1 pathway, JAK state pathway, in different diseases, including cancer. In this study, we found that niclosamide has antiproliferative effects by inducing G1 phase cell cycle accumulation. The cell death effects was associated with apoptosis stimulation, and it has ability to inhibit colony formation and migration efficiency. At the molecular level, we found that niclosamide has ability to induce GSK3 beta phosphorylation. It is the inactive form of this protein. The specific part of this study, we found that niclosamide mediated GSK3 beta regulation is independent to beta catenin pathway. The increased expression of phospho-GSK3 beta inhibits the Hedgehog signaling pathway by inducing the expression of the SUPU, which is the negative regulator of this pathway. In another part, we also found that it has ability to inhibit mTORC1 pathway. By this way, it induces the autophagy, and this autophagy is dependent on inactivation of GSK3 beta. We confirm this experiment by using autophagy inhibitor spoutin, and these results suggested that niclosamide mediated autophagy is important for pancreatic cancer cell death. So this is the schematic representation of this study where we found that niclosamide can induces the phosphorylation of the GSK3 beta. By this way, it acts on the Hedgehog signaling pathway. In first mode, it inhibits the GLI1 translocation, which is the activator of this signaling pathway, as well as it inhibits the translocation of the GLI3, which is the truncated form of the GLI3. And by this way, it inhibits the Hedgehog signaling pathway and inhibits the cellular proliferation of pancreatic cancer cells. In another mode, it inhibits the mTORC1 pathway. By this way, it induces the stimulation of autophagic protein such as backlin-1 and LC3 and leads to autophagy stimulation. As a crosstalk between the autophagy and apoptosis pathway, we found that it inhibits the interaction between the backlin-1 and BCL2. By this way, it induces the apoptosis. So this is the cell death mechanism. So the novel insight of this study, we found that niclosamide inhibits the GSK3 beta pathway. By this way, it inhibits its regulate Hedgehog signaling pathway and mTORC1 pathway. Thank you.